Hey guys, today I thought I'd do a short notes presentation on video just because I'm kind of under the weather and my voice is already kind of going away after first hour here. So hopefully this will help and that you can go revisit it as well. We're only going to cover about 9 slides today. So energy is part of Unit 2. It's very closely related to work, well, in that it essentially is the same thing as work. And so that's why we don't separate it as a different unit altogether. This unit lasts about 4 weeks, and we'll do a couple labs. It's a pretty fun one. Let's define energy. It's simply the ability to do work. We talked about work as being a transfer of energy before. And so let's take a look at what that means. It says how much work is done when a 3 Newton book is lifted to a height of 2 meters. Well, it takes energy to do this work. And if you recall, work is force times distance. We have a force in the 3 newtons. We have a distance moved. They are in agreement. And so we've got 6 joules worth of work here. It says the energy the person used to do the work is now stored in the book because it's been placed in a higher position. How can we get that energy back out? Well, if you were to shove it off that shelf, then that stored energy would become moving energy or kinetic energy. So there's this exchange that goes between those two types. Excuse me. Work and energy are both measured in joules. Many different types of energy here. The one we spend the most time on is probably mechanical energy because it's interesting. Things are moving, so we can work with those a little easier. But take a look at some of the others here. Thermal energy, electromagnetic, which was like the radiation you were talking about in the astronomy unit. Electrical energy, chemical energy stored in things like food or fuels, and then nuclear. Later on this unit, we'll talk about conversions from one to the other. Kinetic energy is one of the main categories. So all these different types you saw could either be classified as one of 2 types, kinetic or potential. So first we're going to look at kinetic energy. Energy due to motion depends on 2 things, how massive the object is and how fast it's going. Obviously, the more massive, the more kinetic energy, and the faster you're going will definitely have a huge impact on kinetic energy. So how could a really small object like a bullet still have a lot of kinetic energy? Well, velocity in the equation is actually much more important. So even though a bullet is super small, because it's going so fast, it actually always has a lot of kinetic energy. Speaking of that formula, here it is. Kinetic energy is equal to 1/2 mv squared. Mass has to be in kilograms, velocity in meters per second, and kinetic energy, just like work, is measured in joules. You have to remember your order of operations here. So if you remember PEMDAS, we deal with parentheses. Well, there's no parentheses here. Exponent comes next. So in other words, you have to square your velocity first. 2 sample problems I want you to try on your own. Pause me after I give the instructions here. So number 1 is talking about a man walking, calculating his kinetic energy. And 2, you have to figure out how fast he's going. That's a little tougher. Pause me here and do these in your notes. Sorry. I'll show the work down here. Let's see here. Help if I have this in the right spot. 1/2 mv squared. So velocity squared is 4 meters per second. So we end up with 1/2 times 70 kilograms times 4. And that should end up with 140 joules, I believe. This other one's a little trickier. You're provided with the kinetic energy, and that's equal to 1/2 mv squared, but we don't know v. So we have to get v by itself. The first step you do is multiply both sides by 2 to get rid of that half. So then, here, let me pull this up. You'd have 2 times kinetic energy, in other words, 5,000, is equal to the mass times v squared. But we got to get v squared by itself. So we're going to divide both sides then by 50. Doing so, This is really ugly units. If you just want to focus on the numbers, that's fine. You'd be left with 100 on one side and then just v squared on the other. To get just v, we need to take the square root then of both sides of the equation. So you'd get 10 meters per second. Wow, I'm really struggling. Slide number 7, we're going to define potential energy. Energy stored as a result of position or shape. We'll be talking mostly about gravitational potential energy. This is when an object is elevated off the ground, and so it depends on 3 factors. Mass, again, how high up this object is from either the ground or some reference point, and then the acceleration due to gravity, which we remember is always 9.8 meters per second squared. The formula is really easy for gravitational potential energy. Sometimes you'll see me write it as GPE, but it's equal to m times g times h. Mass in kilograms again. G is always the same, and then h will be height in meters. So you got a couple other problems here. I'd like you to pause me and try on your own. The first one has us calculating work that he does when he climbs up this platform. Work down here is equal to force times distance. So I'm giving you the force of the man, and he climbs 10 meters. So here's your work right here if you do that math. B says how much potential energy is he storing as he stands on the platform. It's equal to mgh. So you have to use the mass times g times that same height, and lo and behold, you get the exact same number. So what do these two answers show us about work and energy? Well, work is the transfer of this energy, and so they're equal. Second one, again, you have to do a little manipulation. We're given the potential energy, and it's equal to mg, and we don't know h. So in other words, you're going to have to do some division here. You have to take 2450, divide by 50, but then you also have to divide by 9.8. So make sure you check your work and end up getting exactly 5 meters on that problem. Now tomorrow we're going to be working exclusively with different examples like these. If you did okay on these, that should be pretty easy. If you're struggling, then hopefully tomorrow we'll solidify how to do these. At this time, I have a reading that you should open in your Singe text. It's called Describing Energy. And you'll have that open as you complete a really short assignment. It should be a white worksheet that I'll give you today. You can pick it up at the front of the room. Again, Describing Energy is the chapter you should open up in Singe. And then this worksheet will be due tomorrow. Thanks for putting up with this terrible video, but hopefully you can revisit it if you need to. Thanks.